And welcome back, everybody, to another layer by layer tutorial with me, Noel Ruiz. Welcome, everybody, in the chat room. We are live streaming today on YouTube. So if you're watching this on the live stream, be sure to subscribe to the Adafruit channel and hit that little bell icon next to the subscribe button so you know when these things go live. So that's one good way to do it. Or follow us on Twitter. You can do that at twitter.com/Adafruit. Well, so I'm going to do something a little bit different today. I don't actually have the project completed today, but that gives us an opportunity to kind of go through the workflow and see kind of how I go about making a project. So in today's project, you can see here I have lots of feather boards. So if we go over to, let's take a look over here. So Adafruit feather boards are obviously one of the kind of flagship products from Adafruit. It is a kind of bite-sized Arduino variant that comes in many different types here. So if you go to over here, adafruit.com/feather, you can see all the feather boards that we have. And today's goal is to make a general purpose enclosure that is 3D printed and that can house a number, and most of the feather boards, a battery, an on and off switch, and some other accessories like a piezo buzzer or something else. So this project video was actually inspired by Bill Binko, who's actually in the chat room. And Bill started atmakers.org, which is a website and a collection of guides and tutorials to get folks interested in making projects, DIY projects for assistive tech, helping folks get more access to a lot of gadgets and things like that. So check out atmakers.org. There's also a Facebook group that you can check out. All sorts of great stuff going on there. So the main idea was, of course, to again make an enclosure that is multi-purpose, general purpose for folks to use, because a lot of the projects revolve around these main components: a feather board, a battery, and sometimes a piezo buzzer. And so that's what I have here. Back over here. So that's what I have here, just to kind of show you guys what components sort of we're working with today. So one of the cool things about the feather boards is that they all have sort of the same format and footprint, right? But you'll notice that some of them are slightly different in terms of kind of the length over here. The width they're all about the same. But they all have around the same components here in the top here. So we have the USB port for programming and recharging a LiPo battery. Speaking of the LiPo battery, we have a JST connector, which is all on the same spot. The reset button is also all the way in the same spot. So obviously you want to have, in the enclosure, we want to have the ability to have access to the USB port. One thing that I'm noticing is that all of these guys here have different mounting holes, so I'm not going to really worry too much about getting correct positioning for standoffs for the back here, but all of the mounting holes on the front here do have a same footprint. So if you stack these on top of each other, you can kind of see that they are all the same footprint there. So, and that was kind of the goal with the feather boards, is to have some like a universal footprint for them all. Another component I have here is the piezo buzzer. This is sort of the large version. I picked this version because it has two mounting kind of areas here. So that's why I picked that one. It's fairly large and it should be able to kind of fit on top of the enclosure or so. Another thing is the ability to kind of turn the thing on and off. So I typically use this little slide switch, which is okay, but I'm going to kind of use something different. I want to use this guy here, which is an on and off kind of toggle button. So you press it in, it makes a nice clicky sound. And it's a little bit bigger, but I think that's okay. The goal here isn't to make the most smallest thing possible. It's to make the most kind of universal thing possible. And I think this would probably be a better solution than this little guy here. So being able to turn off and on your circuit is always one of those things that you want to keep in mind foremost when you're designing a enclosure for your project. Another thing is I have a bunch of these nylon screws. These are the M25 size screws, which are the exact size of these mounting holes. So these are kind of a new product. We just started carrying these. There's all sorts of standoffs and sizes of different types of. The length of the screws are all different, but they all are M25 size screws. They are, of course, metric screws, not imperial. I think if you wanted to use imperial screws, you could use the 440s. That's the number, whatever code number for the imperial screws. But anyway, I want to, a lot of my projects that have mounting mechanisms for, feather boards use like these little nubs. I don't have one here, but they're basically like these little nubs that you snap into that are a part of the standoff. And the reason why I don't want to do that for this project because not all 3D printers can kind of print those, and they're very kind of prone to break. So that is why I'm kind of opting not to use those. So I want to use these screws. And they're nylon screws, so you're not going to run into like shorting anything out, because if you use metal screws, you could potentially short something out. It doesn't happen a lot, but it is a possibility. So, excuse me. Now I don't have an enclosure designed yet, but I did start kind of modeling some of the components, like this switch here and the piezo buzzer. I do have already designed a Adafruit Feather, this one here, the blue fruit one. But I don't think I need to model all of them. I just have to kind of have enough room to kind of contain all of these guys. So I think I'll be okay there. Now, one good tip, I probably haven't really said it, but it's kind of an obvious thing, is when you're making a project, it is a good idea to kind of just make a document that outlines your goals, your ideas, and product components, right? So before I start doing anything, it is a good idea to just kind of note everything here. So idea, it's a general purpose enclosure for the Adafruit Feather. This will be used in several projects, including Accessible Tech. Some of the goals here is to be able to fit all of the feather boards. So it's got to have enough room for all of the feather boards. It's got to have enough room for a battery, mainly the 2000 milliamp battery. There is there's lots of different types of battery, but I really like using this one a lot. It has the same sort of size as the 1200 milliamp battery, but I like the 2000. It's just a little bit thicker, and why not have more capacity? Obviously a spot for on and off switch. So I have both of them listed here, the tactile one that I showed you and the little slide switch one. A spot for the piezo buzzer. Another cool thing about this is to have different multiple tops, right? So how do you make this general purpose? Well, you have a main enclosure, and then the top will have kind of different things. So maybe it'll have some mounting holes for the piezo buzzer or something else. And being able to kind of swap out the top should be relatively easy. So what I don't have listed here is to kind of make the cover snap fit. So if you guys see a lot of my projects, I like to use these little nub mechanisms where they kind of clamp into the lip of the enclosure. So I want to kind of do that same thing. So you don't need extra screws to kind of mount the cover on top. So I definitely want to do that. Obviously I want to use the nylon screws. So avoiding those nubs because they are prone to break. Another thing is that since it's going to be multi-purpose, we want to be able to kind of have either headers or wires coming out of the enclosure. And a lot of the times when I just make a hole to thread wires through, that can kind of get messy, because if you solder the wires into the pins, you kind of have to thread it through the enclosure, and then you're kind of stuck. And if you want to take out wires, then you kind of have to unsolder it, or maybe you're using jumper cables. So I think having like a little slit through the enclosure is a good idea. That way you can just kind of insert the wires in and out. I think I've done that on a few projects before. And then obviously I have all the boards listed here. Well, not all of them, but the ones that I have access to right now. These are the ones I have on hand. So that's kind of the introduction to the project. Now that I have kind of all that stuff laid out, I guess I could start on the enclosure. Again, I have some of the components already made, so like this little button, which looks kind of weird, but that's the best as I can get it to. This button did not really have any tech drawings. So I just kind of use my calipers to kind of measure out these little notches on the side and the features over here where the wires are. I don't have the wires modeled, but at least I know where the wires are going to be. The other thing is the LiPo battery, which is super simple, just getting that height and width and thickness correct. The piezo buzzer doesn't have too much to it other than those little mounting holes. This one did have some tech drawings, so when you're starting a project with multiple components, it is important to kind of make sure that you have the right features modeled, so that when you design your enclosure, you can kind of get the right dimensions for mounting holes or whatever. So this one had a nice tech drawing, which was surprising because a lot of the components don't. But hey, we have these, so I use that as a reference to model it. So that's following the same stuff there. And then I'm using the Feather M0 Wi-Fi board, which is this guy over here. So this was very, very simple. I didn't model everything, just kind of the main things I need. So the mounting holes, the JST adapter thing here, and the USB port. It is very, very simple. Not much to it. It just doesn't make sense to me to design all of the intricate little features, because as long as you have sort of a general shape, I think you can model around that and be just fine. Okay, so I'm going to take this opportunity to kind of take a look at the chat room, because this is sort of a collaborative thing. See if anybody has any ideas, any questions, anything like that. I do have to kind of scroll a little bit. All right. Let's see. What I'll do in a future stream is kind of integrate the chat room into the kind of snapshot, into the scene for Wirecast, so that folks can see the YouTube stuffs. All right, I think that's all good. I mean, Pedro's in the chat room as well, so he can help anybody have any questions. And if there's generic questions, Pedro can answer. Kirby can as well, Bill as well, so you guys can help me out here if anybody has any things. Maybe tab slots for the outside of the mounted case. Oh, that's a good idea. So the idea of having tabs on the outside of the case will allow people to mount it to other things. That is a good concept. I didn't think of that. So what I'll do is I'll take that note and add it into sort of the goals list here. So tabbed slotted holes on the outside for the mounted case, a lot like how this guy is here, right? If you go to like Radio Shack, I don't know if they're around, but there's a lot of project enclosures that do have these kind of little tabs here, just for that reason, just to kind of have some sort of thing to mount to. I like that idea. I haven't done that in any project yet, so that's a good idea. Cool. I will do that. All right, so let's gonna get started in this enclosure then, shall we? Cool. I'm going to start a new design. And before I even do anything, I'm going to save this out as Featherbox inside my Featherbox project folder. That's good. Next thing we'll do is just import all of the things. Well, not all of them, just the main things. So mainly the feather itself. It's in the center, because I designed it in the center of the grid, which is always nice. All sort of in the center of the grid. It's more on the lower left. Okay, let's see what else. This guy here, the battery. Maybe we'll rotate it. Whoa. Yeah, something like that. I think that we'll import stuff as we kind of make it, because that's okay. We don't have to import everything in yet, so let's try to get this one centered more. So one way to center things is to use the align feature under modify, which I should use more, so that's why I'm going to try to use it more. So the idea with align is that you can kind of get things aligned with other objects or faces. There we go. So there's a couple options here under align. Flip it, or you can angle it. I guess angle's okay. Let me try to flip it now. That flips it the wrong way. Cool. Oh, they added capture position now to the align. That's kind of interesting. That way it kind of takes a snapshot of where all the stuff is. Obviously, I probably don't want to have it on the bottom of it because then I can't get screws to it unless they were from the top. Looking at it this way, you kind of see like, yeah, I rarely ever have the feather on top of the battery like that. That just kind of happened that way. So let's move that up here somewhere.
People want to see the Fusion screen bigger.
Oh, oops, I don't have the Fusion screen. Thank you, Pedro. Live stream, that's what happened. So, you didn't miss much. I am just moving stuff around. Cool. All right. So, what I've done so far is simply just imported objects and kind of moved them relative to each other. So, I used the align feature to do that, which is kind of neat. And what I'll do next is kind of, I'm not following my own advice here, where if you're going to move objects once you've imported them, make sure you kind of capture the position once and then work within that one captured feature thing. Because when you're moving things around, you tend to develop a bunch of these move commands that are on the bottom here in the timeline. So I obviously am rushing through it, but I'm going to slow down a little bit and make this think a little bit more about it. All right, so I'm going to move this guy up like that. Okay. And finish capture position. Okay, so that's all I've done so far. I imported these two objects and then captured the position. And I think it really doesn't matter where you are in the grid, but if you can design in the center of your grid, why not be in the center? So I'm not sure if I'm in the exact center, but hey, I think that's okay. All right, next thing I'm going to do is kind of make our component for the enclosure itself. So let's do that. And I will start off with a sketch on the bottom, like that. I'm going to do a circular rectangle since I'm working from the center. I'm just going to drag it out. When you're making a rectangle, you have the option to set dimensions, but I don't think I want to do that. I want to set dimensions kind of relative to other things. So I've done this before where I project in geometry from an existing component and then I set dimensions depending on that. So let me get rid of this guy here. I just kind of got there with a mistake. So the way to do that is you can project. So let's say I want to project the battery here, and that gets projected. I hit P on my keyboard and then I clicked on the surface, and it projects that into the sketch, and you can tell it's a projected sketch because it has these purplish edges, lines. So then I'll do I'll use the dimension tool to kind of define a constraint. So I want to say I want this edge to be a certain distance from that edge. And that way I can always move things around and kind of, if I ever move things around, then it kind of adapts to it, right? So I'll do that for all the edges here. Okay, now it's saying it's over constrained, which is kind of a bad thing. I don't want that, but I think it is, whenever that happens, it's normally something you don't think about because constraints kind of get applied automatically, and sometimes that can be bad. So what I think it is it's this guy here. I think that's a parallel sketch dimension, which doesn't really make sense to me why it would kind of prohibit me or make it over constrained, or maybe I already did that, that's why. Whoops. Okay, let's do this last one here, or second to last one. 5, and then this one, and it's saying it's over constrained again. Let's see what we have. I guess I did them all. So we have 5 here, 5 over here, 5 over here. I think that's all of them, yeah. Okay. So 5 millimeters should hopefully be enough distance. Since it's all 5, why not make a user parameter so I can quickly adjust that one thing. So let's call it margin. I don't know a better word. So I'm just going to call it margin, put 5, hit enter. So now that I have that, I should be able to just modify to say margin. Thinking about it like or padding would have been another word, but I think margin is okay. Cool. So that way, if I ever want to increase the margin, it'll kind of work across all of them. So I think that's okay. Now, one thing I always want to make sure is that I have enough room from the JST connector so that I have clearance for the battery connector to actually plug into the Featherboard. So that's fine. And then looking at the USB port, I kind of need that to be on the edge, because if I make it this way, I'll have to like force the entire USB connector into the enclosure, and that's not going to work so well. So instead of having a constraint here or a margin here, I should just put like something like 1 millimeter, which is pretty good. So that means I kind of want to have the battery more shifted to the left, because I want it to be away from that USB port, because if I have it perfectly in the center, I'm not going to be close enough to actually reach the USB port. So let's go back into our thing here, and you'll notice that my timeline is now kind of, hey, where'd all my stuff go? Well, see where it says hide all inactive features? Let's turn that off so we can actually see we don't have a lot of features or components yet, so it's okay to turn that off. So I'm going to go into my first capture position and move that battery over. Let's do that. Move it that way. And we'll kind of figure out a better way to kind of, a lot of the times I just kind of throw a battery in there and good luck, right? You could make a nice kind of holder for the battery, so maybe it's like a little cavity or something, or these little walls that kind of hold it in place. That way the battery just doesn't jiggle around inside everywhere. All right. It looks like our main sketch kind of got all messed up, which is fine. I don't think I have what do you call it? A constraint set over here. And it doesn't look like I don't have any degrees of freedom anymore. So I'm trying to kind of move this over, but it doesn't seem to be working. Why is that? Normally, you kind of get a dimension, but it's not there, so I'm not sure why it's stuck there. Let me try setting a collinear, saying like, hey, this edge needs to go over here. Yeah, it's like, nope, I can't do it. Failed to resolve. Huh. Why, Fusion? When this happens, sometimes the best thing is just kind of draw it again. It is a little frustrating that it doesn't want to. I just don't see why it's over constrained. I don't have a specific dimension set to it, and if I try to set one, it says it's overdriven, which is bonkers. Like, why is that overdriven? Doesn't make much sense to me. Could be a bug. I don't think it is a bug. I think I just don't see what happened there. So what I'll probably do is just kind of, start a little fresh here. Such a simple thing, and it's like, really? Really? Okay, let's start, because we didn't really do much work there, so why not delete it, right? Okay. There's a dot there. Sometimes the center, or actually all the time, the center rectangle stuff bears a bunch of extra constraints. So I think something in there kind of goofed up, and it's not deleting now, which is super weird. Yeah, let's go ahead and delete sketch 1 and start a new sketch.
Okay, Bill's saying that the center rectangle has a default symmetry.
Yeah, it certainly does. Yeah, it certainly does, and it's a little weird. So maybe not use the central one, just use a regular 2.1. I think would work well. So we want to encompass the whole thing, right? Probably start like over here. I'm not going to set any dimensions yet. I'm just going to kind of make a general thing, and then what I'll do is I guess I'll project in a couple things. So I'll project that in, then maybe set a constraint over here.
And then he's saying to put the battery underneath to have the OLED or the NeoPixel rings on top.
Oh, that is such a good point. Oh man. So I'm trying to avoid doing that because how do I mount it then, right? I'll have to mount it to the top, right? Mm-hmm. So you kind of have these screws coming from the bottom of the board and then into the cover. I think we can do that. I have not done that yet. That's kind of interesting.
I mean,
but then that's not gonna work because if you have a screen or whatever wing, then how am I gonna mount that board to it? So, that is a problem. Yeah, that's why I don't put the battery underneath the board.
It says make it 2 layers.
Make it 2 layers?
Yeah, so it's on the top and the bottom, so there's like a little separator, I'm thinking.
Oh. I think you've done that before, right? With like the Chargito case?
Yeah.
Where you have like a separate enclosure that snaps into the main enclosure?
Mm-hmm. To the bottom part of it.
Yeah. Oh, man.
That would work.
Yeah. I think it's still relatively simple if we're doing that. This is fun. This is fun because it's like we're sketching and designing as we're planning.
Kirby says magnets. But magnets may interfere with any medical stuff, maybe.
Yeah, I guess. Magnets for what though?
To hold the 2 layers together.
Oh, interesting.
I used pins,
yeah.
which they were pretty thick, so
oh, I see what you're saying. These nubs or pins would kind of snap into other things. Yeah.
They were okay, but I did have to print out a new case because they did eventually break off on me.
Yeah. But ideally, there wouldn't be a battery, then I wouldn't have to worry about the battery.
Well, I had to use a battery.
Yeah, and then you have to kind of make a hole for the battery housing to kind of
for the
thread through the bottom and then go into the JST connector.
That's interesting. Cylinder battery. It's not going to be the smallest with a cylinder battery.
Cylindrical battery. Yeah. Yeah, I tend to go with more of the flat one. But why not a cylinder battery, right? Because then it would be next to the board and not on bottom or the top. It would just be next to the board.
Want me to bring you a what is it?
So the single cell one is a 2200 one. Let's take a look at that. That's a good point, Kirby. Let me go to over here. Yeah, so this is the cylindrical type LiPo battery. Lithium ion, not LiPo. Yeah, so these guys, different shape, right, for the battery, and that allows me to sort of have it next to the feather board. Yeah. Yeah, it could be on the side of it, right?
So you can visually see.
Medical's not an issue. Okay. That's what builds. Yeah, so the idea would be let's look over here on the side. The idea would be to kind of, instead of having let's just pick one feather board for now. Kind of clear this out and kind of prototype this a little bit. So the problem is I can't have this mounted over here because what I was thinking is that I typically screw from the bottom here, so the enclosure would be here, and I can't poke through the battery, right? And then if I have it on top, which I was planning to do, then I can't put a feather wing, right, an accessory, so maybe it's an OLED or a NeoPixel display or something. You kind of cover it if you put the battery there. So putting it on the side is what might work better. So this is actually, it's a little bit thicker, but I don't think thickness is a problem here for this project. Again, the goal isn't to make the smallest thing. So having it just be next to the feather might not be a problem, because then I don't have to worry about kind of mounting this to a cover. So I can kind of have it this way. Then obviously you can have the battery routed this way. So this might be a good idea. And what I've done before, I actually used this battery on the Pygro project, and what I did was I made this little U shape that snaps into the enclosure. So you literally just go and it snaps into the enclosure. So that's one way to kind of keep it in place. Cool. So what Pedro brought me over here is his enclosure for an Apple Watch charger or a Qi charger. And the way he was able to do this was, it is a two-piece thing.
No. I added screws on the bottom, so it's being held.
So the screw goes all the way into this? Oh, that was nubs.
There used to be nubs.
Oh, all right. So there's a battery encased in here, right?
Mm-hmm.
So it's sort of like a two-part thing.
Yeah.
You mind if I take it apart?
Mm-hmm.
Cool. This is an interesting project because I'm thinking, oh, it's such a simple enclosure. It's like, well, when you think about all of the, it's kind of harder because you have a lot of situations where you have to think about them before designing the enclosure. No, I think it's okay. They're just really long screws. If you were to redo this project, Pedro, would you use the nubs?
The nubs?
Yeah, the kind of like clamping nubs, the little triangular nubs. Would that work here? I think so. I mean, the enclosure probably gets
secure the screws make it, because I take this every time we travel, so I never have to worry about any like boating or bending or anything like that.
Yeah, but if you look at the enclosure, like that one right there, that's right next to me, the brown one there, that's not gonna. You can throw it on the floor and it's never gonna come apart because it's like clamping onto it so well that you might as well break the enclosure if you want to get to it, right? So just a thought, because screws are.
It's just for removing it, but it's really secure. Careful in taking it apart.
Oh, there's one here too.
Yeah, that's how the clip is held on.
Interesting.
So eventually I do have to use a screw to
hold
something in
sometimes
place.
you just need. Well, I wanted to use screws because those knobs kind of tend to break. Okay, so we're inside, and there's a hole there, and this comes off, right?
The other side. There's screws on the other side.
Holy jeez. This thing is madly secure.
Yeah.
And this is a great thing, too, is to
Again,
always wrap your battery in some sort of protection thing. In this case, it's just gaffer's tape. So, cool. So that's one solution, is to have the battery housed underneath here. But then again, you have like all these screws and stuff. Maybe that's not a bad thing. I don't know if I should continue You kind of get it. Oh, I see. So this is a frame too. So there's like two covers.
Yep.
Is it a problem that there's a bunch of parts? Maybe not.
Is it for Bill that there's a bunch of parts?
Well, I mean,
for me it wasn't a problem.
Right, you just print the parts.
Mm-hmm.
Right. I don't know if I need to open it. Do we want to go this route?
I mean, it's the 2-layer solution.
Right. I'm just... So, I can't remove these two parts, right?
Should be able to. I think you gotta get all the screws out.
Right, okay. This takes forever.
See, Bill's saying that you could have the battery slide in from the side. I mean, but you still have to physically connect the JST.
But then it could slide out, right?
Yeah, that too. It could slide out as well.
Right.
This is why I have like all these screws to hold everything together.
If it slides in, then you need some sort of... You get an overhang, right? If you're printing it flat, you might have this overhang thing to deal with. I think the majority of the show is now unscrewing things. I'm fearful that like everything's gonna fall out, so maybe do it this way. I haven't looked at this project in a while, so I can see the pegs. Yeah, they're in there. They're in there really good. That's another thing. Like, I don't want to break those pegs, and by forcefully pulling them out,
yeah, it might break.
It might break. So this was printed flat, and then those nibs print out upwards, so you don't have to worry about anything there. Wow, that's interesting. And then there's standoffs there to mount that in place.
Yeah, one tried separating it.
Okay, well, that's one solution, guys. Is to kind of have these two sort of frames.
Yeah, that's almost exactly what I have here. Except that it slides in.
Right.
But when it slides in, you still have to plug in the JST.
Is there a bunch of, what do you call it? Support material, though, for the top there?
Well, you printed in 2 parts.
The top?
You printed in 2 parts. Just like I did there. And then you connect them together with long screws.
Right. Where's the brightness? So here's the what Bill is recommending is to kind of just insert the battery in there. Yeah. So it's a lot like this one, but instead of the cover, you just have this.
I guess you could have a JST panel extension that comes out towards
right.
The bottom
You still need kind of some
together.
sort of hole, I think, to thread that the cable, the battery cable into. Mm-hmm. That keeps it, relatively thin, I guess, right? Thinner than this solution. Yeah. I kind of like this because it's really tough, right? Like, this is mad tough. Like, I could drop this on the floor and it won't explode or bend. These guys certainly will. So I feel a compelling reason to use this guy.
But if you're printing it in 2 parts, which is why I layered it together, it's going to have the protection of the gaffer's tape, and it's going to have the protection of the 2 parts that are completely separated.
True. This one has more capacity.
Which one?
This one. Yeah. It has like 200 milliamps more capacity. The Feather can charge both, right?
Yeah. Should be able to.
I think so. Alright, so now I'm at a fork in the road where which way do I go? Do I go with the cylindrical battery, or do I go with the puffy, the little packet
square.
Here?
I like the square.
You like the square? Bill, what do you think, man? He probably wants the square too. Yeah, most do use lipos. Mainly, it's sort of our choice too, and it's like, Okay, yeah. So the other compelling reason is that the 2-part solution just allows you to have different size batteries, so you can use a 1200 one. Yeah.
You could use smaller ones and then add more components inside of here. We have a new 400 milliamp hour battery coming in too.
Mm-hmm.
So.
Yeah. Okay, we're right there. All right. So I guess we're all leaning towards the lipos. Jason is saying it's heavier. I don't think that's an issue. Like, weight, I don't think is an issue. Is this one significantly heavy?
Not significantly, no.
Oh, that's a good idea. Adafruit should sponsor a feather case contest and give away a feather. That's a good idea. I'll ask Phil and Lamar and see if that's a thing we can do. I'm sure it is. That way we have a lot of brains on this and not just mine. But that was kind of the goal here, was to kind of ideate a couple of concepts and see what works the best. Yeah, a lot of people don't have a 3D printer writer, and that's one of the things that's really good about 3D Hubs and AT Makers is that you can kind of ask the community and see if folks are willing to kind of 3D print these parts for people. Well, I think one of the goals for AT Makers is to kind of get in contact with education institutions and get those idle 3D printers to print out these projects that can really help people out. Yeah, and of course, that my ideal thing is to make the enclosure without a battery, so you just kind of keep it plugged in through the USB, and you have an external battery source. That is probably the easiest thing to do, right? Yeah, that'd be the easier thing to do. Is no battery, in there. Yep. AT Makers also just did a stream about 3D printing services, so getting in touch with not just local operators but your school as well. Like more and more high schools and universities are getting these 3D printers, and they don't know what to do with them. All right.
It says finish off the stream by just finishing up the top part of the case without a battery. Don't worry about the bottom for now.
Yeah. So
I say just go this route.
really,
Yeah, just
right.
2 parts.
And then we can just kind of build on top of it. So, all right. This one. Yeah. So, yeah, so ideally, I guess what we're going to go with is making it so let's not worry about the battery right now. Kind of the simple thing to do is to get an enclosure for just the feather. Let's say we want to have an external battery source. Let's do something like that. See how it's kind of floating up a little bit? Let me get that more down. So I would go back into this guy and just kind of move this down. So that's the floor, right? That's like the red line, which is like, I guess, the x-axis. That's kind of going to be the floor of it. So I like to have kind of like a little bit of room. Especially, I don't tend to have the bottom of the PCB flush with the surface of the 3D printed thing. So what, we got like a 1 millimeter distance.
We got another vote for the module layer stacking on top would accommodate various battery sizes and
right
accessories.
Okay. Yeah, okay. So let's say we got that, and I'll extrude this up kind of like this. What I like to do is just kind of make the box first, right? So encase the whole thing, encase the whole components, in this case just the feather. And then what I'll do is I will just do a shell. So I like using this shell a lot instead of kind of manually making the width, because then you can always change this thickness here. You could even put like a user parameter and say, how thick do you want this enclosure, right? Which I should probably do that. Let's do that. So part of margin will have a case thickness. 1.5 is my magic number. So when I go back into that shell, I'm just going to say thickness. And maybe what's cool is that we can reuse this over and over again and just kind of say, oh, we want a thicker case, or we want it more this way or that way. And why not add some fillets? I'm a big, huge fan of fillets. Or fillets, whatever they're called. Maybe 3. And there we go. All right, so we're kind of looking like an enclosure. You'll notice that I am now intersecting with the board. You can see here it's kind of cutting into the board, so I need to go back into this guy here and just kind of maybe make that 2 millimeters. And there we go. We have a little bit of clearance there. If I wanted to make a cutout for the USB port, I would kind of sketch on this guy and kind of bring in that geometry from the feather board. So let me hide that for a second. And just kind of project in that guy. Always a good idea to have an offset for your ports, whether it's a USB port or an Ethernet port. It doesn't matter. Yo, where'd it go? There we go. And then kind of break up this closed loop here, this profile with by selecting one of the lines and hitting X to do a sketch thing. So now I can just select that one thing, and then extrude this out. Bring back the case thing. Change my direction, or not direction, but my extent to object. That one. That way it's dynamic if I were to go there. So now we have a little bit of opening. We got that going on. I don't think we need to have any. Well, obviously we probably want to have some holes here, or here probably somewhere in the case, so that you can get external components connected to it. If you're using a feather wing, obviously you wouldn't need the holes. This is a little thick. Make another one. Call it like case height. Maybe make it 10. So the extrusion was what, right here? Yeah. Let's make that height, case height. There we go. That's looking kind of thin. And that's not too bad. So obviously the battery thing would make a hole here or something. That way you can thread, or maybe over here, that way you can thread the cable. So how do we mount this thing, right? So the way I would do it is make a sketch on this floor here, the surface. Oh, I forgot to capture the position, really? I thought I already did. That's weird. Components have moved. Really? I don't remember them moving.
Because he put the slit for the wires on the opposite end of the USB.
Yeah, I would agree. Like on the opposite end of the USB, so somewhere over here would work well. So kind of like, this is where I probably use a center rectangle. It doesn't matter where the slit is, but I mean, you know. Something like that. That way I can kind of move this over extent to here. Okay, so there's a little slit. That way wires, you can make it thicker obviously if we modify the sketch. Just kind of prototyping it out. Normally don't worry about this like overhang. I usually just kind of print it fine. Yeah, it's always fine. You can do some pretty long bridges, and that's not, what's the length? It's like 9.6 millimeters. That's not a problem at all. Cool.
See, Terry's wondering if it's worthwhile to add a window to the case to monitor onboard LEDs. I think you can break out the LED status, can't you?
You certainly could break that. You could. It's more work.
Depending on the case, though, it should be transparent enough to.
You
see
could
the
print
light.
it in a white or light colored or translucent material. That way you can kind of see all the lights and stuff.
Even with this gray.
I was going to work on the mounting mechanism. So this one's like the main case body. I think that's the USB cut. And this one is it's going to be the mounting standoffs, and this one is the slit. Maybe wire slit. So it's easy to kind of get a mounting standoff here. So I can kind of project in these mounting holes. And again, I don't really want to worry about these mounting holes on the back, because the feathers, that's where they do differentiate, is the mounting holes on the back, because some of them are a little bit bigger than others, just enough to where the mounting hole wouldn't make sense. So I think 2 of them is fine. So let me hide that. And you can make a square or something.
I mean, if you make it long
I just
enough,
like to offset them.
If you make it so it's big enough and as big as the longest feather.
Oh, I still want to have standoffs to keep it upright, to keep it level, but they won't have holes in them, right? Because that's where they differentiate, right? The holes.
I mean, you could add multiple standoffs, like what I was doing with most of the projects.
they're too kind of close though.
They're too close.
Yeah, I mean look at them all. You can see they're literally like, off a little bit.
Yeah.
Yeah. So we got these little holes here, or these little. Oh, let me make the holes first. Extrude, extent, make it go to the bottom here. So those are holes. That's where the screws are gonna go. Those nylon screws.
Mm.
And then I need to elevate the PCB somehow, and I'll do that by extruding these guys, little tubes, standoffs. Bring them up. What I'll do is instead of putting a fixed number, I'll tell it the extent to be dynamic. So I'll say extent to object, and that's the bottom of the PCB. And bring back the body so that it glues to it. It says there's an error because Fusion now defaults to chain faces, but it should be to extended faces. Not a problem, just change that, hit OK. So you can kind of see now it's elevated a little bit. They're really short, so what I'll do is go back into that guy in that capture position and kind of move it up a little bit, maybe by 1 millimeter.
And then for the top, maybe make it so you can switch out the. We're already thinking that, right? So different tops. So
yeah, different tops.
One could be like longer to accommodate headers being on there.
Taller, right?
Yeah, taller.
Yeah, taller, absolutely. Yep. And the tallness right now, it's definitely too short. You can see that the JST connector is already like kind of poking through. So what I did was I added a user parameter, so I could say, oh, it's 14. Boom, done. I don't have to go into a sketch or anything. It's just there. That's good. But once you get a feather wing, so like an OLED, for example, I might want to model the feather wing. I don't have one modeled yet.
Didn't it come in today?
Yesterday. Yeah, I have them. And we would probably use these guys, right? These large stacking. Well, they're not large. They're just kind of common. Let me switch screens to show you guys what I'm talking about. So, use kind of just standard female headers, right? So that you can snap another thing on here. That's how it works, right?
Mm-hmm. We have different sizes of those.
Right, but I would go with these because they're I think they're kind of standard. So the feather wing would go on top of here, and you want to have enough height for these guys. You can see it extends a little bit beyond the JST connector. Yeah. Back to CAD. So we're getting somewhere. Let me go ahead and save. And I'll probably take a break soon because I gotta do bathroom things. But let me do a quick recap here. So what we covered today was to kind of ideate the project and play with the different concepts of how to get a battery. We kind of got a little stuck there, a little fork in the road, where it's like which battery should I use and where should the battery be underneath, on the bottom, on top, on the side. And I think what we're going to do is create its own battery area, because what's cool is since it's a multi-purpose enclosure, you will have the option to either have an external battery source or have more of these batteries or this battery or whatever battery you want, right? Or plug it into the wall. So that way we'll thinking about being open to different power sources. Yeah. This was fun. This was different. I usually kind of recap what I've already done, and I haven't done anything for this yet. Mm-hmm. So there's a lot of things to think about.
Yeah, comments. Yes, they do make a load profile ones.
Absolutely, I have them. I use them.
Load profile for
yeah.
I forgot what. The watch.
But I don't think that's not really important here, right? Making a small enclosure that's super thin and small is not important at all here, right? Can we agree on that? It's about what is more available, and I think these are, but I mean it's up to you. I don't know. If you get short, is it shorter than the JST connector? Because if you are, then you're going to run into you're going to intersect with this guy. You
That's
see what I'm
true.
saying?
Yes.
So
I actually had to use a mix. I had to use the
mix.
the feet because we have the low profile ones. That's a male and a female. So I had to use I think the female longer one and then a male short one.
Huh.
So
What project
you
was
can
that?
mix it. The MicroPython watch.
Oh, okay. Right, because that one, you had like 3 stacks of feathers, and it's like this thick sandwich.
Yeah.
Which is kind of fun.
And that's what I ran into, where the low profile one would go into the
Yep.
JST.
I know what you mean. All right. Cool. Anything else in the chat room, guys, that you want to...
Bill is saying if you could share the file that you have so far.
Absolutely, yeah. Let me do that. The quickest way. You could reuse the components, I think, too. I think... yeah, there's a thing with either sharing the whole project or sharing the folder. I don't think you can share a folder unless you invite email, and I don't think I want to share Bill's email here. But what I'll do is anybody can grab this. So that's the public file. Right, just for this one thing. It should include the feather and the battery, but I'm gonna invite you to the whole project in itself, and anybody else wants to, we can do that itself. There's this new branching mechanism here, so that people can fork the thing, and you won't come up with conflictions and things. So I think that's pretty neat. So if you guys want to be a part of the of this project, let me know, and I will add you as a contributor. I think. I don't know how else to invite someone to this. Is it this little cogwheel?
That's a good idea too. Make the height so that the headers stick out of the tops.
Yeah, we could do that too. That way it's just enclosing a little bit of it. Yeah. All right. Cool. Well, let me do comments,
that. People are requesting a parametric feather doubler.
Feather doubler? Mm-hmm. Like the PCB?
Mm-hmm. A case for it, I'm guessing.
Oh, okay. Sure. That's a cool idea. And to see, the feather doubler is like where you don't just stack up ways, you go across, right? Mm-hmm. Is that the whole goal with that one? Okay. Cool. All right. Any last remarks? Anybody? Oh yeah, no, not a problem. Bill is saying, don't stress over it being non-polished. People learn by watching. You struggle. Yeah, it's absolutely. Yeah, I knew not having a plan with this, with a lot of the live streams, you just kind of go through it. So you don't have to be perfect. No, that's why it's parametric, right? No, it's okay. You can just go in there and change it up. Cool. Well, this was fun. Let me guys know if you guys have any suggestions or any ideas or things like that. We are always open to constructive criticism. That's going to be it for me today. Pedro, thank you so much for joining me here. This was fun. We're actually going to do the 3D Hangouts tomorrow. We're going to have a special guest. Right? We're still on for the special guests?
Should be, yeah.
I'm not going to say who they are, but we're going to have some special guests. It'll be a little bit different of a show tomorrow. That is 3D Hangouts at 11 a.m. Eastern Time. So hopefully we'll see you guys there. All right, that's going to be it for me. I am going to go to the bathroom.
See you guys.
I'll see you guys later. Bye, guys.
See you tomorrow.